In this question, we're asked about the addition of HCl to methylamine. The first thing to recognize is that HCl, so hydrochloric acid, is a strong acid and that methylamine is a weak base. So the reaction between them is that we have methylamine and HCl. If we put those together, the strong acid is going to react as much as it can to give the weak conjugate acid of our base, and that will now have the chloride anion. And so if I draw in my Rice tables, the reaction, initial, change, and equilibrium, I started with 1 mole of methylamine, so 1.0 mole. I need to figure out how much HCl I started with. I have 1.0 molar, so 1 mole per liter HCl, and we have 250 milliliters of it, so that's 0.250 liters. So that means we are adding 0.25 moles of HCl, so our initial is 0.25 moles of HCl. And we start with no conjugate acid. A strong acid like hydrochloric acid is going to react as much as it can. Our weak base is in excess, so all of the strong acid is going to react. So we have minus 0.25 mole, minus 0.25 mole, and on the other side, that is the amount of weak conjugate acid that we're going to make. So at equilibrium, what we have is 0.75 moles of our weak base. We have no strong acid left, it's completely reacted, and we have 0.25 moles of our weak conjugate acid. Now we can recognize that we have a weak base and it's weak conjugate acid within a 10-to-1 ratio, which means that we have a buffer, so we're able to use the Henderson-Hasselbalch equation. So our pH is equal to the pKa plus the log of the moles of conjugate base over conjugate acid. And so here our pKa was given in the question for the conjugate acid. It was given as 10.64. And then plus the log of the weak base, which is 0.75 moles, over the weak acid, which is 0.25 moles. So it's okay to use either moles or concentrations when we're working with a buffer, since the volumes will simply cancel out. If we plug this in, we'll find that the pH in this case is 11.12, and that is the pH of the solution when we add this strong acid to our weak base.